All right, so just a friendly reminder that next week you will not have a live lesson. I will post some sort of recorded video for you to watch and then practice for you to work on, probably of the same stuff we've been covering the last couple of weeks. So just wanted to give you a heads up on that. So if we try to find the parabola's vertex, the vertex is that red point right here marked on the bottom of the parabola. We want to figure out where that's located on the graph and where that has shifted from 0, 0. So take a second to identify that vertex and tell me how it has shifted from 0, 0. So the vertex is at 3, comma 5 on the graph, which tells us from 0, 0, we went right 3 units, and then we went up 5 units. Let's try another one. Find the vertex, tell me the orientation this time, and then how has the vertex shifted from 0, 0? All right, so this vertex is located at -2, -4. I had to go left 2, which is why the x value is -2, and down 4 to get to that vertex. And the orientation is positive because the ends of the parabolas are facing upwards. All right, so let's take a look at these two equations and these two graphs, and tell me what you notice and what you wonder. All right, so if we look carefully at those parabolas, one of them has a positive orientation, the other one has a negative orientation. And they're both sitting at 0, 0, and they don't cross over the x-axis. So if you look at the equation, what's the only difference in the equations over here? The only difference is that the second one has a negative sign at the very front of the equation. And that is what created our second graph having the negative orientation. So if we put a negative sign at the very beginning of that equation, we're going to have a parabola that has a negative orientation on the graph. All right, go ahead and take a look at this set of equations and graphs. See if you can write down what do you notice and what do you wonder. All right, so if we look at these graphs, notice that the first parabola sits at 0, 0. The second parabola has shifted up 5 units. And the last parabola's vertex was shifted down 5 units. So look at the equation and how might that connect to those shifts on those second two parabolas? So if you look at the equations, you see that the second one says x squared plus 5. So that's literally telling us to take our original equation, our original parabola, and shift it up 5 units on the graph, which is what we see here in this second graph, starting at 0, 0 and going up 5 units. And then for equation 3, it looks the same, but with the minus 5 at the very end of the equation. So we're taking our parabola starting at 0, 0, and we're shifting it down 5 units on the graph. Let's take a look at these three equations and graphs. So if we look at these equations and graphs, notice that this time the equations have parentheses in them. We haven't seen that yet. So notice on the graphs that we're also seeing a new type of transformation or shift occurring to the graph as well. The graphs this time are moving left and right. So if we look at the original one, the vertex is at 0, 0. If we look at the second one, we have shifted right 3 units. And if we look at the last one and start at 0, 0, we have shifted left 3 units. So if we look at the equations there, notice that each of the second and third equations has parentheses around the x and the 3. And the only difference there is one is a minus and one is a plus. Now, the second equation goes with the second graph. So notice that even though our first equation has a minus, we shifted to the right. And even though our second equation has a plus, or excuse me, our third equation has a plus, it shifted to the left. So this is called, you have been investigating the vertex form of a quadratic function. So this is what it looks like. Notice we have the letter A at the very beginning of the equation. In parentheses, it says x minus h, and at the very end, it says plus k. The vertex, the reason this is called the vertex form is because it tells us the vertex and it tells us the orientation without doing any work, without having a calculator, without having a graph. We can know those two things about the parabola. So the a value, the number at the very beginning of the equation, is going to tell us the orientation. So if this is a positive number, it can be positive 1, positive 7, positive 2.5, doesn't matter what it is. If it's a positive number, then the graph is going to have a positive orientation or be facing upwards. But if that a value at the beginning of the equation is negative, then it's going to have a negative orientation, which means it's going to be facing downwards. So let's take a look at an example of this. So taking a look at this equation, f of x, is the a value positive or negative? So remember, the a value is the number right after the equal sign, and it is -1 in this case. Okay, so there, we see a negative sign there, which means our a value is -1. So if since our a value is -1, what would the graph of this parabola have to look like? This is going to look like graph 2 because a negative a value means we're going to have a negative orientation. Okay? Negative a value means we have a negative orientation. All right, so that's our a value. So now let's look at our h value, and that's that number there in the parentheses. So notice that the h value is with the x, so that's going to tie to the x value of the vertex. And the most important part about the h value is that it's the opposite from the equation into the graph. And we'll dig more into why that is, but you really just want to focus on the fact that it's the opposite. So if I look at this equation, y equals x minus 4, that means the parabola is going to shift to the right 4 units, okay? Which means my x value of my vertex is at 4. If I look at the second one over here on the right-hand side, it says x plus 4 in the parentheses. So that means I'm actually going to go the opposite direction, which means to the left. So my vertex shifted from 0, 0 to the left 4 units. And then the k value, that number at the very, very end of the equation, that describes the shifts up or down. So if we put a plus something at the end of the equation, like if you look at this example, plus 3, that tells us that our k value is 3, which means our vertex moved up 3 units. If the k value is a negative number, so for example, x squared minus 3, that would tell me that my parabola shifts down 3 units. Okay, so A tells us the orientation, H tells us if it's shifting right or left, and it's the opposite of the sign that we see in the parentheses, and the K value tells us if we are shifting up or down. So go ahead and look at this example and tell me, what do you think the vertex is? So remember, to find the x value of the vertex, we're going to look inside the parentheses and do the opposite sign. So that's going to be a positive 3. And then we're going to use the number at the end of the equation and keep it as is, which is a positive 1. So the vertex would be positive 3, positive 1. What is the orientation of this parabola? And then fill in the blanks in this statement. The vertex shifted blank 3 and blank 1. So the orientation is going to be positive because we don't have a negative sign at the very beginning. So if you don't see a negative sign right after the equal sign, then the orientation is going to be positive. And then this tells us that the vertex shifted right 3 and up 1. All right, so let's take a look at this example. Which equation below correctly represents a parabola with a vertex of 11, 6 with a positive orientation? All right, so that's going to be the first equation. So the first thing I want to look at is that it has a positive orientation. So I'm automatically going to eliminate these last two options because they don't have a positive orientation since they have the minus sign at the very beginning of the equation. And then remember, I take my x value of my vertex and I do the opposite. So since this says positive 11, I'm going to look at the equation that says minus 11 in the parentheses. And then the plus 6 stays the same. So now let's practice a few examples of this. So if I look at this first example, Function g of x minus 6 squared minus 7. The vertex would be 6 comma negative 7 because I'm going to take and flip the sign in the parentheses and keep the sign of the last one, which tells me I went right 6 and down 7, and it has a positive orientation. So look at that second example there, f of x, and fill in the vertex. The vertex is going to be positive 2 because I'm going to flip the sign from what I see in the parentheses, and positive 4 because I'm going to keep that number the same. So now fill in the rest of that table. So my vertex of 2, 4 tells me that I went right 2 and up 4. And this parabola has a negative orientation because of that negative sign there at the very beginning of the parabola. Go ahead and try h of x. Fill in all of the table. All right, so the vertex is going to be at -3, -1, which means I went left 3 and down 1, and my orientation would be positive. All right, so write the vertex based on this equation and then choose which graph correctly represents this vertex. All right, so we're going to flip the sign from in the parentheses. So the vertex is going to be at -2 and then +4. So the graph shifts left 2 and up 4, and it's got a positive orientation because there's no negative sign there at the very beginning. So that's going to be graph 3. All right, so for your exit slip, find the vertex, find the orientation, and then sketch a graph of this parabola. And then don't forget about your independent practice in Google Classroom. And remember that I will not see you live next week. You will have a recorded video with an assignment to watch.